Probably one of the most important methodologies as it relates to the field of statistics is the Pearson product moment correlation. Now, you might also hear this referred to as just a correlation or simply as Pearson's, but whenever you hear a speaker referring to either Pearson's or correlation, what they're referring to is the Pearson product moment correlation. So what I'm going to do in this video is I'm going to demonstrate how to apply the Pearson product moment correlation in SPSS. But before I do such, I'm going to give you a little bit of an outline, a little bit of the history, and a little bit about the actual method itself, which hopefully will make it clear as to when the method is appropriate to apply and what some of the reservations are that you should have prior to applying it. I'll also show you how to report your results in APA format. So just first a bit about the definition of the Pearson product moment correlation. The Pearson product moment correlation coefficient, or Pearson correlation coefficient for short, is a measure of the strength of a linear association between two variables and is denoted by R. So here are a couple model assumptions. The two variables should be measured on a continuous scale. The two continuous variables should be paired 1-to-1. There should be independence of cases. There should be a linear relationship between your two continuous variables. Theoretically, both continuous variables should follow a bivariate normal distribution, and there should be no univariate or multivariate outliers. So here are a couple quick guidelines as it relates to interpreting the Pearson correlation coefficient once you have the output from the test application. And we'll discuss this once we have our output as it relates to our example. So here is our SPSS data. You can pause the video here and input this data yourself into SPSS if you so choose, or you can get the code, which is in the video description below. The data is in CSV format, so you'll have to go ahead and get that and then import it into SPSS if you so choose. So I've already gone ahead and input this data. So let's go to our example here. Here is our data in SPSS. So the first thing we're going to want to do is actually perform the Pearson product moment correlation application. So to do that, we're going to go to Analyze. We're then going to select Correlate, and then we're going to select Bivariate. Now, I've already been playing around a bit with this, but for your needs, make sure that both of your variables are placed in the variable box to the right. As far as all the options are concerned here, you can just leave these be, but make sure the variables you're interested in are in the box to the right. Once you have those there, go ahead and click OK. Your SPSS output should display something which resembles what is displayed on screen here. And we'll go over this in a moment. If we're going to be reporting our findings in APA format, you're going to have to do this in additional step as well. You're going to have to go to Analyze, then select Compare Means, then select Means. Make sure both of your variables, if not so already, are in the dependent list box. So select those. Make sure they're in the dependent list box to the right. You can click Options and make sure that we have mean and standard deviation in our cell statistics box. If they're not there, place them there, but by default, they ought to be there. Then click Continue, and then click OK. And this will provide us with some additional output in our SPSS output window. So now we have everything we need to make our assessment as it relates to this particular methodology application. So returning now to the slides. Here is our output from the screens. Here is our interpretation guidelines. And here is how we're going to put the data in APA format. So first, we're going to state the strength of the correlation. So we do that by interpreting the R value. So the R value, which is to two significant figures, 1.3, is right here. Okay? So Pearson correlation, 0.129, we're going to round that to two significant figures, and that's positive 0.13. So we see there's a positive correlation because the value is positive. It's not negative. If it was negative, it'd be a negative correlation. But because this value 0.13 is positive, there's a positive correlation. And because the value is between 0.13 and 0.3, it's a small positive correlation. So there was a small positive correlation between the two variables, x and y. Now you can put the number of observations if you would like, but you can just say the variable name, so x and y, apples and oranges, whatever your variable names are. We then need to state, if we're stating our findings in APA format, the mean and standard deviation of each of our variables. So for x, our mean is 0.480. Remember, we're going with two significant figures in each instance. Our standard deviation is 3.80. Excuse me, it's 3.79, not rounding it up. It's 3.79. That's our standard deviation. Our mean for y is 79, and the standard deviation is 14.35. Now we have to state our conditionals, and this is a bit tricky because the output that you need for the remainder of the APA format is not in SPSS as far as default output is concerned. So you have to calculate some of these values yourself. So for T, we need to find the degrees of freedom and place it here. Degrees of freedom is the number of observations, n, subtracted by 2. So n minus 2 is our degrees of freedom. 10 observations minus 2 is 8, right? So 8 goes there because 10 minus 2 equals 8. Now, as far as the t value, this is a bit tricky, okay? So what you need to do is you need to either use a graphing calculator or a calculator or Excel or R, any of those platforms or methods, and you have to utilize this equation here. Now, be very careful with order of operations. It's going to be the value of R, which was 0.13, multiplied by the square root of this, of the entirety of this calculation here, n minus 2, n being the number of observations, so 10 minus 2 in parens, divided by 1 minus r, which is 0.13 squared. So you have to first do n minus 2. Then once you have that value, you're going to divide that by 1 minus r squared. Okay? And then you're going to divide the one value by the other. Then you're going to take the square root of that value, whatever the value of all of those calculations is. You're going to take the square root of it, and then you're going to multiply it again by the r value, which was 0.13. And from that, we then have our t value here, which is 0.37. Our p value is 0.72, and we get that from over here. It's two significant figures. So 0.723 in our output is 0.72, and the Pearson product moment correlation coefficient is 0.13, right there. And remember, that's what we were utilizing to determine the strength of association and whether it was positive or negative. So there's some confusion now if you're meeting with your research team, or maybe you're meeting with your professor after you turn in your assignment, but there's often confusion as it relates to the p-value versus the r value in this particular output and method. The p-value is indicating as to whether there was a significant correlation determined. The Pearson product moment correlation coefficient value, R, indicates the strength of the model or the strength of the association. So the p-value is going to inform you how likely the associated relationship happened by chance, and the R value is measuring the strength and direction of the variable association. If you wanted more information, you could visit this site here. I'll put a link to it in the description. And this is where we're going to end. So if you enjoyed this video, please consider liking and subscribing. If you have any questions, maybe leave a comment so we can all help one another out. We're trying to get the message out to as many users as possible, so best of luck in your research. Thanks for stopping by, and until next time, take care.